Okay, so your question reads, a bucket is being lowered by a cable. The tension or force in the cable is larger than the force of gravity on the bucket. What can we say about the motion of the bucket? How can we describe it? So, just to recap, so you're lowering a bucket. We're told that the tension is greater than the force of gravity on the bucket. All right, so following our logic model, we want to imagine what forces are interacting on the object that we care about. And that object, of course, in this case, is the bucket. So what are our interactions? Well, we have the force of gravity. That will always, of course, be one of our interactions. That's between the bucket and the earth. And we also have the tension, the string. So the force of the string, which string, rope, chain, we often call that a tension T. And that's between the bucket and the string. All right, and we're going to assume a massless string in all cases, unless otherwise noted. Okay, we're told that the tension is greater than the force of gravity, the weight. And so if I draw a free body diagram of my bucket, I know that my tension, this is the arrow that represents the weight of the bucket. My tension is larger than the weight of the bucket. So my arrow points up. And now we can follow our logic model. So if the top arrow is bigger than the bottom arrow, the sum of the forces is upward. The ups are winning. The sum of the forces is positive. If the sum of the forces is positive, this implies that the acceleration is positive. Acceleration and forces act in the same direction. If the acceleration is positive and I am told I am lowering my bucket, well, the velocity of the bucket is negative. I'm told that in the problem. I'm told it's lowering. Positive acceleration, negative motion, these are opposite, which implies slowing down. So I'm raising the bucket up, but it's coming to a stop. It's slowing down. So that's how we describe the motion of the bucket given the information that we have. Good job.